So we were previously talking about this while loop where we were defining a product without a product operator. And we want to make sure that this is a correct algorithm. So remember, we use the idea of loop invariance here. So what will our loop invariant be? I'm going to use in, and it's going to be the statement I equals n, and we want the product to be equal to n times x. And let's identify our guard. So our guard comes from this part about while. So our guard condition is that I is not equal to m. That's our guard condition. And so last time I laid out the procedure, there are 4 steps you need to show, and we're going to work through them here for this example. So the first one was called a basis property. I'm going to say what that means here. So for us, we need to show that I0 is true before the first iteration of the loop. So what is I0? If I plug in 0 into my definition for in, it would tell me that this is I0 is I equals 0, and the product is equal to 0 times x. And this is true before the first iteration of the loop, because we were told at the beginning in the precondition I equals 0, and the product was defined to be 0 as well. So we've just checked the basis property. Now let's look at the inductive property. So what do we need to show here? We need to show if our guard and IK is true before a loop iteration and k is greater than or equal to 0, then IK plus 1 is true after the loop iteration. So this is kind of similar to induction. You're assuming that IK is true and showing that IK plus 1 is true. So we're going to suppose k is greater than or equal to 0 such that G and IK is true before, I'll say, before an iteration of the loop. Well, since our guard, since G is true, I know that I is not equal to m, and also because I know IK is true, I know that the product is set to be kx, and I is equal to k. So because I is not equal to m, we pass through our guard. The guard is passed, and we start executing the loop. So the first thing we're going to do is execute statement 1. So we redefine product. So our old product is K times X, and then our new product gets redefined as the old product plus X. So this becomes KX plus X, or if you factor out the X, it's K plus 1 times X. So then once statement 1 is executed, the next step is statement 2 in the loop is executed. And so our old value of I was K, and our new value of I is the old value plus 1. So it becomes K plus 1. So then let's look at what we have. The new value is K plus 1. Our product got changed to K plus 1 times X. And so now I can say after the loop iteration, I, K plus 1 is true. And this completes our inductive property.